Welcome to the DIY Honda Garage channel. The diagnostic trouble code P2185 indicates an issue with the Engine Coolant Temperature ECT Sensor 2. This DTC is specific to the Honda Accord model years 2008 to 2012. The ECT sensor plays a crucial role in monitoring the temperature of the engine coolant, which helps the engine control module, ECM, manage engine performance, fuel efficiency, and emissions. Sensor 2 is generally located near the engine block, and its proper functioning ensures accurate readings for optimal engine operation. When the ECT Sensor 2 circuit shows high voltage or indicates a reading of approximately -40 degrees Fahrenheit or less, it triggers this DTC. The troubleshooting process begins by gathering relevant diagnostic data before proceeding with any electrical or mechanical inspections. The DTC P2185 pertains to the Engine Coolant Temperature ECT Sensor 2, which is integral to engine management systems. This sensor monitors the temperature of the engine coolant, relaying crucial information to the engine control module, ECM. The ECM uses temperature readings to adjust fuel injection and ignition timing, ensuring efficient engine performance and reduced emissions. Sensor 2 is typically located near the engine block or cylinder head, making it susceptible to various environmental factors, such as heat and moisture. It's essential to understand that a high voltage reading or an impossible temperature reading, like -40 degrees Fahrenheit, indicates a fault in the sensor circuit. Proper diagnosis involves understanding the sensor's role and symptoms when it fails to provide accurate data. When diagnosing the DTC P2185, several possible causes should be considered. First, the ECT Sensor 2 itself might be faulty, potentially due to age or damage from heat exposure. Next, electrical connection issues, such as corroded terminals or loose connectors at the ECT sensor or ECM, may interrupt the signal, causing the circuit to register as high voltage. Additionally, a short circuit in the wiring or a problem in the harness could lead to erroneous readings. It's crucial to meticulously inspect these components to ascertain the root cause of the code. Each factor plays a significant role in how effectively the engine performs and in maintaining optimal operating temperatures. The symptoms related to the DTC P2185 can be significant and may impact daily driving experiences. Drivers may notice engine performance issues such as stalling, rough idling, or poor acceleration due to incorrect temperature reading inputs. Furthermore, increased fuel consumption may occur as a result of the engine performing inefficiently. This happens because the ECM cannot optimize fuel delivery without accurate coolant temperature data. Additionally, the check engine light will be illuminated on the dashboard, alerting the driver to a need for diagnostic attention. Understanding these symptoms is essential for timely repairs and ensuring the vehicle operates smoothly. To start troubleshooting the DTC P2185, turn the ignition switch to the on/to position. This action activates the vehicle's electrical systems, allowing for data readings. Next, use the Honda Diagnostic System, HDS, to check the ECT Sensor 2 in the data list. It is important to determine if the temperature indicates about -40 degrees Fahrenheit, -50 degrees Celsius or less, or if the voltage is 4.92 volts or higher. If these readings are extreme, it suggests a potential fault with the sensor itself or related circuitry. Ensure that the data recorded is accurate, as this is pivotal for the subsequent steps in the troubleshooting process. After verifying the readings of the ECT Sensor 2, if the indication shows approximately -40 degrees Fahrenheit or less, or a voltage of 4.92 volts or more, proceed to check for intermittent failures. In such cases, the system may be functioning normally, and the next step is to investigate for poor connections or loose terminals at the ECT Sensor 2 and the Engine Control Module or Powertrain Control Module, ECM/PCM. Use appropriate diagnostic equipment to identify and rectify any connectivity issues. Ensure that all connections are secure and free from corrosion, as these factors can significantly affect sensor performance and data accuracy. Next in the troubleshooting sequence, turn the ignition switch to the lock 0 position to safely disconnect electrical components. Following this, detach the ECT Sensor 2's 2-pin connector. This action will allow for a further investigation of the circuit. Prepare a jumper wire to connect the terminals of the ECT sensor's 2-pin connector. This step is crucial as it helps in simulating sensor operation, letting you determine if the issue lies within the sensor itself or elsewhere in the circuitry. Ensure the wiring is suitable for the task to avoid any short circuits or additional errors. In this step, connect the jumper wire to the terminals number 1 and number 2 of the ECT Sensor 2 2P connector. This connection effectively bypasses the sensor, allowing you to check the voltage signal directly. Once the jumper wire is secure, turn the ignition switch back to the on 2 position. Again, use the HDS to check the ECT Sensor 2 data. It is essential to see if the reading is about -40 degrees Fahrenheit or less DT Celsius, or if the voltage is at or above 4.92 volts. Should the readings exhibit these conditions, your diagnostics will lead to the next steps without further circuit investigation. After confirming the expected readings with the jumper in place, turn the ignition switch to lock 0 once again. Safely remove the jumper wire from the ECT Sensor 2 2P connector now. It is necessary to revert to the actual sensor for further tests. Following the removal of the jumper wire, turn the ignition switch back to the on 2 position, enabling the system to resume normal function with the ECT sensor connected. This step is vital for valid testing of the sensor against baseline conditions without any modifications or bypasses. Now, it's time to measure the voltage present at the ECT Sensor 2 2P connector terminal number 1, specifically against body ground. This step is instrumental in determining if the sensor circuit has any faults that could lead to high voltage readings. A proper multimeter should be used for accurate measurements, and the reading should show about 5 volts. A reading close to this indicates that the sensor circuit is likely intact and functioning as it should. If the results deviate significantly from this expected value, it may suggest issues within the wiring or possibilities of a defective ECM/PCM. Speak with clarity to ensure understanding of each component's role in the entire system. Once all the diagnosed issues have been addressed, it's crucial to perform final repair verification for the DTC P2185. First, confirm that all necessary repairs were executed thoroughly and correctly. Afterward, use diagnostic tools to check for any remaining diagnostic trouble codes, DTCs, ensuring that the previous issues have been successfully resolved. Next, conduct a test drive of the vehicle under normal operating conditions. This final step is essential, as it allows for observation of the vehicle's performance in real time. Verify that the check engine light does not illuminate, and the system operates smoothly without returning to the fault state. To prevent future occurrences of DTC P2185, establishing a routine preventive maintenance schedule is prudent. Regularly inspecting the ECT sensor for damage, wear, or corrosion can catch issues before they escalate. Ensure that all electrical connections remain clean and secure. Loose or corroded connections can lead to erroneous signals. Additionally, monitor coolant levels and quality to maintain optimal engine temperatures, which are vital for efficient performance. Keeping an eye on these factors plays a pivotal role in preventing sensor faults and prolonging the overall health of the vehicle's engine management system. In conclusion, understanding the role of the Engine Coolant Temperature ECT Sensor 2 is foundational for effective diagnostics concerning DTC P2185. Throughout the troubleshooting process, adhere strictly to the outlined steps for accurate diagnosis and repair. Each step provides critical information about potential failures and directs the technician toward potential resolutions. Furthermore, regular maintenance, including checking the sensor and electrical connections, is vital to ensure long-term vehicle reliability. Finally, staying informed about common issues within the Honda Accord models from 2008 to 2012 helps in addressing concerns swiftly and efficiently, thereby enhancing overall vehicle performance. Please like and subscribe to the channel. See you next time.